So I have a small problem. Actually, I have about 3 small problems. So my son, Jack, just got a new Power Wheels toy for his birthday. And if you know anything about these toys, they're these tiny little cars that kids can sit in, and they're battery powered and they can drive them around your yard. And it's a ton of fun because they feel like they have their very own little car, just like we do as adults. But there's some issues that we found so far as he's been using this toy. The first issue is that the battery just runs out quickly and you can't hot swap the battery. Meaning, if you want to use the toy more, you have to stop it and charge it using the provided charger that plugs into the lead acid battery that comes with the toy. Now, battery modifications on these toys are nothing new. There's a million videos on YouTube. If you just search Power Wheels battery mod or Power Wheels battery swap, you'll know what I'm talking about. But I think we can start there, but add a few more key touches that I really haven't seen too many other people do on the internet with these toys yet. Because the second problem is that we don't have a fence around our yard. So theoretically, our son could just drive into the road with his Power Wheels toy, which could obviously be a bad situation. Now, it goes without saying, we don't let our son out of our sight when he's using this toy, but I think we can design some safety measures to make sure that if he leaves a predefined area, the toy will automatically shut off. And the third problem is that our son keeps running into stuff with his new toy. That could be our house, it could be trees in the yard, and most recently, it's my wife. It's turned into a bit of a game where he sees my wife in the yard or his mom and he wants to go drive after her. And even though we tell him no, he gets a big kick out of it. So I think we can design a system that will integrate with the toy and make sure that we can easily swap the battery when it runs out so the fun can continue. The toy will not leave a predefined area of our yard to ensure that he cannot drive into the road with his toy. And the third thing we can do is design in a system to make sure that the toy can actually detect obstacles in front and in rear, just like our normal cars would when we're parking, to make sure that he can stay safe and the toy stays intact. And my wife's sanity is not tested too much. So with that in mind, let's get into some of the components that we're gonna use for this specific build. So the first thing is going to be which battery we're going to use. So I just happen to own Milwaukee tools. So I have these Milwaukee M18 lithium ion batteries. So we need a way to actually connect this battery up to the rest of the system, which is where these adapters that you can buy for just about any sort of power tool battery come in really handy. And again, this is where there are about a million different videos online about how to retrofit these Power Wheels toys with these batteries. So that's great. However, our son is only 2 years old, so I don't necessarily want to just run 18 volts directly into the motors because that will result in a faster Power Wheels toy, right? So that's gonna be great when he gets older, so there's some future proofing there, but I need a way to step down this 18 volts to 12 volts, which is what the toy originally takes. So to do that, we're going to use what's called a step-down converter. So this is a component that allows us to take 18 volts from this battery and turns it into 12 volts that will match the original voltage of the battery so that we don't actually speed the toy up. And again, some people might be disappointed by this, and you can actually totally run these directly into the motors and that's okay, but until our son gets a little bit older, we're gonna keep it at 12 volts. So this component eventually will be able to be removed. So this step-down converter, as you can see, is super beefy and it has these cooling fins along it because this thing can handle about 30 amps. However, we need to actually step it down one more time for sensitive electronics. So we need to go again from the 12 volts to 5 volts, which is where this additional step-down converter will come in really handy. And this is actually adjustable so that we can adjust the output voltage for whatever we need. But we're actually going to use 5 volts because that's what our Arduino and various sensors run off of. Speaking of, we need a way to detect obstacles when our son is getting close to them in his Power Wheels toy. So that's where these off-the-shelf ultrasonic sensors are really handy. Now, these ultrasonic sensors are really cool because at their core, it's actually the same technology that cars use to detect obstacles when you're parking. The way they work is they actually bounce a sound beam off of the obstacle that might be in front of it. And based on the time it takes for that sound beam to return to the sensor, it can actually calculate distance. So what we can do is we can set a minimum distance to detect so that if an obstacle is approaching, we can shut off the power wheels. But it's not just obstacle detection that we need to add to this system. We also need to understand where in the world our son is actually driving his Power Wheels toy. That's where a GPS sensor will come in really handy. So what this will allow us to do is to define a predetermined geofenced area. And what I mean by geofenced area is just an area defined by certain latitude and longitudinal points that we can define as a boundary, so that if this sensor exceeds those boundaries, then the system will automatically shut off. So that's why GPS is going to be great. But we actually need something to interpret all of the signals coming in from these sensors and flip a relay, which will cut power to the whole system. And to do that, we're going to use an Arduino microcontroller. And in our case, this is actually an Arduino clone that happens to be a lot cheaper. Now, Arduinos are really cool because what they do is they take predetermined instructions that you load onto them using the USB port, and it runs those instructions in a loop over and over and over. So if we give it instructions to look for obstacles using our ultrasonic sensors, and to determine if the Power Wheels toy has exceeded a geofenced area using our GPS sensor, then the Arduino can detect that and send a signal to our relay, which will turn off the system and keep our son safe on his Power Wheels toy. So with that in mind, let's actually wire up all of these components using something called a breadboard to test to see if some software will actually work to do what we want to do. Now that we have an idea of which sensors we're going to use to fix some of the problems that we talked about, let's actually build a rig to bring it all together. So what I did here is I took my breadboard and just 3D printed a small frame that I could attach all the sensors to, as well as give some space for the relay on the breadboard in addition to the Arduino. So all that you see here, even though this might look kind of crazy, is just these ultrasonic sensors attached to the Arduino, along with the GPS system right here, and then the relay right here, which is going to be what either enables or disables the power on the Power Wheels toy, right? So everything's wired up, and the idea is that this system will allow me to more easily carry this around and test it before we actually put it on the toy itself. So this allows us to test everything on a small portable rig to get everything working, and then finally we can install everything on the Power Wheels toy itself. The first key step of this system will be to determine a polygon around our yard using latitude and longitude points captured from Google Maps. So each of these points creates a corner of the polygon that we'll use to determine if the car is inside or outside of the allowed area. The code on our Arduino will then constantly check the current location of the GPS module and see if it's either inside or outside of that predetermined polygon area using an algorithm called point and polygon. Then, once we test the software, it's time to bring the car back so we can start to think about implementing these sensors on the car itself. So now that my neighbors officially think that I'm nuts walking around with my laptop rig detecting if I can get GPS signals using our little portable setup that we talked about there just a second ago, we can at least start to put our focus on this little vehicle itself now that we've validated that the software and sensors are working properly. So what I think we're gonna do is, using this little indented area on the front, is mount our ultrasonic sensors there, run wiring back underneath the chassis to a little cavity underneath the seat where a lot of the other components can be housed. And then on the back of this thing, there's this little notch that's right behind the seat that I think will be perfect to design another little 3D printed enclosure where we can actually mount the battery and the ultrasonic sensors and the GPS, so it's really easily accessible and we can hot swap those batteries as needed. So let's look at the front to determine how we're going to design this little front enclosure for this ultrasonic sensor. Now, first things first, let's get this countertop covered because I spent way too much time in a previous video sanding this thing down and making it nice. These little cars are actually surprisingly light, so it wasn't hard to get it up on this countertop so we can get a better look at this front grille. Now, if you're wondering what I'm doing moving my phone around the front of this thing, I'm actually using my iPhone's LiDAR sensor to capture a digital replica of the front grille of this thing so I can see what my designs are going to look like on the real thing. Next, it was time to remove this seat to see how much space we had to work with underneath to house all of our electronics. It's kind of funny, they give you so much space underneath this thing, it's almost like they're asking you to modify these things. Or maybe that's just my engineering nerdy self talking. Next, we could remove the wire cover along the bottom of the chassis and poke a hole in the front so we can get our ultrasonic sensor wire run underneath the vehicle. Throw on a few zip ties and it's pretty secure. Then it was super easy to run this wire into that cavity underneath the seat using this little opening at the bottom of the vehicle. At that point, I could replace the cover for the wires underneath. Now we can think about where we want to mount our GPS module, and I thought that the headrest of this thing would make the best location to get the GPS antenna in the highest possible position with as little obstructions as possible. A few dabs of hot glue later, and this thing was looking pretty sturdy. Once we close the seat back up, you can't even tell there's a sensor in this thing when it's fully assembled. We could then turn our focus to the battery mounting system and the rear ultrasonic sensor mount. I was able to snag a few measurements from the existing adapter for the batteries, as well as a few measurements from the vehicle itself. This allowed me to 3D print a mount for the battery adapter using a material called ASA. Now, the main thing to know about ASA is that it's a lot like ABS in that it's really durable and it has UV resistance, so it's great for outdoor applications, but it doesn't put off as many fumes as ABS does. We could then fit the battery adapter into this mount to make sure that everything was fitting and the holes were lining up properly. I then used a dab of hot glue to keep the battery adapter in place before we screw it on, as well as some hot glue to keep the ultrasonic sensor in place. And these things really don't need a lot of force to keep in place, just a little something to make sure they don't wiggle free. And then once everything was assembled, it all looked pretty self-contained. You can see how this thing just kind of hangs off the back of the vehicle, and once you add some screws, it's actually really secure. It can handle a decent amount of weight. It's actually super necessary because it takes quite a bit of force to snap these batteries into place. Once these things are on this adapter, they're not going anywhere. This solution should fix our problem of running out of batteries so that if we run out of batteries with one of these things, we can just swap it out and keep going. Then it was time to wire up all the ultrasonic sensors. Now, I'm going to explain why this was a mistake later in the video and actually caused me a ton of headaches, but you get the general idea, is we want to wire up the front ultrasonic sensors and the rear ultrasonic sensors securely so that they're not going anywhere. In addition, we want to use these little connectors to attach and detach the step-down converter to the battery so that if we need to remove it for any reason, it's pretty easy. And note to self, if you're going to do this project in the future, find a more ergonomic setup than I was using because my back hated me after this thing. We could then start to make some more permanent modifications. So the first thing we had to do was snip the battery leads off and use this little clamp-on adapter to make it easy to attach and detach the rest of the system to the existing motor controller. I then 3D printed a pretty basic little platform that we could use to attach all of our electronics after we remove the existing lead-acid battery. Again, hot glue for the win here. We could then think about how we were going to solder up all of the connections to our microcontroller so that no matter how many bumps we went over in the road, none of these things were going to be knocked loose. Admittedly, you normally don't want to solder directly to an Arduino like that. I just didn't have any connectors that would make for a temporary secure connection. Regardless, once all the soldering was done, we could start to hot glue all the components onto the small platform that we designed previously. Now, this was not a clean wiring job, but it seemed to do the trick. Finally, we could attach all of these little forward pin connections to our sensors and be ready to go. It was time for the moment of truth of connecting our battery, and you can see the little red light indicating that power is flowing correctly. It was time to attach this headrest with the GPS unit inside of it and make sure that everything was anchored back into place using the original screws. So now we get into one of the scariest parts of any bigger electronics project, which is connecting everything up in the real system. Now we have to actually run a few test scripts to make sure all the sensors are connected properly before we can load up the final software to see if this thing will actually work. So let's start with testing the GPS module in the head seat here. All right, to test the GPS module, we're gonna hook it up to our computer here. Everything seems to be powered on, and we have this GPS test script, which is just gonna output latitude and longitude coordinates to the serial monitor. So let's load it up. Oh boy. Always good when compiling the sketch takes forever. Let's try this again. Just gonna go ahead and unplug that. All right, let's try this again. There we go. There we go. Hey. All right, we're getting data from the GPS module. Fantastic. All right, so that means the GPS module is connected correctly. Let's go on to the ultrasonic sensors now. All right, we're gonna do the same thing with the ultrasonic sensors. Just open a simple sketch. All right, it's uploaded. Oh, good. 0 centimeters. That's a good sign. Okay, so this probably means that, yep, we're not getting anything from the ultrasonic sensors. We couldn't win them all. Okay, I'm gonna check a few things and try this again. Yeah, so you know when I said that it was a mistake to solder directly to these ultrasonic sensor circuit boards? Well, it turns out I just completely ruined the connection and needed to replace them to get the connection working again with the existing headers. When they were working, I could mount them back up and be ready to go. All right, so the battery's plugged in. Let's turn it on. Okay. Now let's see if it actually responds to obstacles. Turns it off. Turns it back on. All right, let's try the front. Yes. Oh my goodness. Oh, it took so much longer than it should have. All right, I'm gonna clean up these electronics and then we're gonna take this outside and test it out there. I then used the charging cord compartment to actually house a USB cord so I could program this thing on the fly. Once that was done, I could then reattach the seat to cover up all these new electronics, so the Power Wheels toy really doesn't look that much different from an old one. And one more detail to finish this thing off. After working out all the little issues of the system, it was finally time to test. Here you can see me trying to drive the Power Wheels toy into the road, and the lights shut off indicating that the power has been cut using the GPS sensor. I'm trying to do my best to show you that I'm not faking this by continuously hitting the little button to move it forward, and you can see when the lights shut off, it's immobilized and it won't go anywhere into the road. Now look, for an experienced engineer, this would have been such a small, simple little project, but I was so stoked to see this thing finally work. And here you can see when I try to drive it into the door, it'll stop itself and not allow me to proceed any further. Now, I was super excited about all this, but I think it's time to show it to the boss. Yeah. That's pretty cool, man. Now, as much fun as I had actually working on this thing, it was way more fun to see my son use this thing in practice. Keeping him from running into stuff, keeping him from driving into the road, which here you can see he tried to do, and the system actually shut down before he could get anywhere near the road, which was awesome. And then you can also see how Dad served as his best possible pit crew to keep him going even when his battery ran out. All this to say, he could spend more time having fun and we could spend less time worrying about him running into stuff. That smile says it all. So you guys, that's gonna do it. Hopefully you enjoyed this Power Wheels project where we could get my son to have a ton of fun in his new toy while keeping him safe. Now, this is just a small reminder, if you haven't already, consider liking and subscribing to the channel because these videos take a lot of effort to produce, but it is so worth it when you see people getting enjoyment out of this sort of positive, creative content. Because more than anything, I really hope this sort of content inspires you to build something in your own life. So as always, thank you so much for watching. I'll see you in the next one.